We're continuing on in section 8.6 here. Now, the area of a rectangle is 8x squared plus 22x plus 15. What are the possible dimensions of the rectangle? Here we're going to look and double check, are there any common factors we can take out? 8 is 2 times 4, which is 2 times 2. And 15 is just 3 and 5. So there's nothing common there. And there's no variables at the end of my 15, which means I can't take out any variables. So as far as greatest common factors go, we just have 1, we can't take anything out. So we are going to factor. My first step is going to be to swing. Okay, I'm going to move that 8 to the back as multiplication. Now, I'm going to factor. I'm going to multiply to 120 and add to 22. My options for 120, 1 times 120, that doesn't work. If I take 120 and divide it by 2, I get 60. Again, that doesn't add to 22. If I divide by 3, I get 40. Doesn't work. If I divide by 4, I get 30. That doesn't work. If I divide by 5, I get 24. That doesn't work. If I divide by 6, I get 20. Again, still doesn't add to 22. Dividing by 7 doesn't work. Dividing by 8 gives me 15. When I add up there, I get 23, so I'm close. Dividing by 9 doesn't work. Dividing by 10 gives me 10 and 12. So here, that's my last set of factors that are possible because 11 doesn't go in. It's also my pair that I'm looking for here. So we did have to go through quite a few options there, and that's sometimes why it's helpful to go in order, because that makes sure we don't miss any. If you would have recognized off the top of your head, well, 120 is 12 times 10, and that adds up to 22, then go for it. But if you're looking for your factors, I recommend going in order just to make sure there aren't any we miss. And again, we get those values by taking 120 divided by 2, 120 divided by 5, and whatever we get is the other factor that multiplies to there. So 120, we multiplied to a positive 120. Our signs are the same because we found the sum both positive. And again, to multiply to x squared is x and x. 120 we said was 10 and 12. Now, remember that we have to undo our swing. So, instead of doing multiplication by 8, we are now going to divide by 8. We have to undo the things that we did to change our expression. Reduce our fractions if we can. 10 divided by 8 is 5 over 4. And 12 divided by 8 is 3 over 2. Now our last step is to undo that swing. So we've undone the multiplication, now we have to undo our swing and move from the denominator back in front of our x. Here I get 4x plus 5 and 2x plus 3. So the possible dimensions of my rectangle here are 4x plus 5 and 2x plus 3. We can double check that here real quick by foiling it back. 4 times 2 is 8, x squared. Outsides, 12x. Insides, 10x. Lasts, 15. 8x squared plus 22x plus 15. And that checks. So we are correct here. In example 4, we're going to factor out a monomial first. If we look here between 18, 33, and 12, they have a common factor of a 3. If you're not sure, guys, break them down like we did before. 18 is 2 times 9. 9 is 3 times 3. So here I have 2 times 3 times 3 times x times x. 33 is 3 times 11. So I put a 3 in my 3 column. I make an 11 column. And I have a negative, so a negative 1 column, and an x. 12 is 4 times 3, which is 2 times 2. I put a 3 in my 3 column, 2 in my 2 column, and I make another 2 column. I don't have any x's. What I do have, though, is a common 3. So my greatest common factor is 3. Now I multiply by everything that's left. 6x squared minus 11x plus 4. And again, we could have done the same thing if we'd have recognized that all of these are divisible by 3. We could have just divided them by 3, put our 3 in the front, and multiplied by what we had left. That would have worked as well. Now, we're not done factoring this. We still have to factor the middle. And in order to do that, our polynomial, I'm going to use my swing method here. So my 3 stays out front. Everything still needs to be accounted for because we still need to be able to multiply back to what we originally had. Now I have x squared minus 11x plus 24. So we're going to multiply to 24 and add to 11. My options for 24, 1 and 24 doesn't work. 2 and 12 doesn't work. 3 and 8 adds to 11. That's what we're going to use here. So again, we keep our 3 in front. It still needs to be accounted for. Unless we have an equal sign, guys, we can't get rid of anything completely. We can rewrite it, but in our expression, it still has to all be there. Because we added, we found the sum, our signs are going to be the same. Here, because our middle sign is negative, they're both going to be negative. And again, to multiply to x squared is x times x. 24 we said is 8 and 3. And double check, even when our signs are the same, our bigger number still gets that sign in the middle. So that's always a good double check just to make sure you're on the right track there. Now, we have to undo our swing. So up here I multiplied by 6 to move my a from the front to the back. I have to divide by 6 then to undo that. Here, 3 over 6 is half, and 8 over 6 is 4 over 3 if I divide by 2. Final step is to swing to the front. Swing our denominator to the front. We undo that swing. So here is my factored form of my polynomial. Let's double check. So I'm going to multiply it back. When I FOIL here, I'm actually going to multiply my binomials first. 6x squared minus 8x minus 3x plus 4. Combine my like terms. And now I'm going to multiply that whole thing by my 3, and I distribute that in. So I get 18x squared minus 33x plus 12, which checks in our original. So this answer is correct. Now feel free to pause here and give this a try if you'd like. If we look, we have 8, 36, and 20. They're all even. So we know that we're going to be able to factor out something. We're just not sure what it is at first glance. So if you recognize that we can take out a 4 because 8, 36, and 20 are all divisible by 4, perfect. If not, go ahead and factor them the same way that we have. 8 is 2 times 2 times 2, x squared. 36 is 2 times 2 times 3 times 3. We also have a negative in front, so a negative 1 and an x. 20 is 4 times 5, which is 2 times 2. We don't have a 5, but I do have room for a negative 1. Common factors here are 2 and 2, and we multiply those together to get 4. So we can take a 4 out of each of these pieces. And what we have left is 2x squared minus 9x minus 5. And again, if you recognize that 4 was our greatest common factor, we could have just divided by 4. But it's important that you have your greatest common factor, because if we'd have only divided out a 2 and we'd have used the swing method, the other 2's would have canceled and we couldn't have gotten back to our original problem. So you need to be very careful there. We need our greatest common factor taken out. Now we're going to factor what's inside. I'm going to swing my 2 to the back as multiplication. We're going to multiply to 10, subtract to 9. Our options for 10 are 1 and 10, which subtract to 9. We also could have tried 2 and 5, but that doesn't subtract to 9. So here I'm going to rewrite this in my factored form. To multiply to x squared is x and x. Since we subtracted, we found the difference, and we're going to have different signs. And the sign in the middle tells us that our bigger number, 10, is going to be negative. Now we have to undo our swing. So because we multiplied by 2, I have to divide by 2. We reduce our fractions and then swing to the front any denominators that are left. And they become the coefficients of our linear binomial there. Here is our factored form. Now to double check this, I'm going to FOIL firsts, outsides, insides, lasts, combine my like terms, and keep in mind that it's still being multiplied by this 4. When I distribute the 4 back in, I get 8x squared minus 36x minus 20, which matches our original, so we know that we are correct. Here's a quick recap here on section 8.6. Some trinomials of the form ax squared plus bx plus c can be factored to equivalent forms, which are the product of two binomials. Sometimes the greatest common monomial factor of the polynomial needs to be factored out before the remaining polynomial is factored. And that's all I have for section 8.6.